For the third time, the who's who in quantum computing software comes to Munich. We have quantum computers, we have quantum applications, but it needs software to bring them together, and this is why the community gathered here for these 2 days.
It's my first year at the Munich Quantum Software Forum, and I'm definitely gonna come back. It's fantastic. Great energy from Robert and the team. It's fantastic to see them all in one room and making many more new acquaintances. I think it's very important to bring computer science theorists, researchers and developers to an event like this.
Oh, quantum software is where it's at, right? So everybody says how quantum hardware is going to be so fast. Well, it's not fast. Quantum computers are very, very slow. Quantum algorithms are new, they're not classical, they have distinct phenomena, and it really changes the realm when we actually talk about programming such things. The software needs brand new tools, all new ideas to develop these true fast applications.
I've been here also already for the first conference, and I found it really great that there's one place where everyone is gathered and was just talking about quantum software. Yeah, I feel like the field is growing. Now there are about 300 people here at this conference, and I think this is great. I was talking to a lot of key players here, and this was really helpful.
Yeah, I was very happy to see how lively it is. I saw a lot of questions of different kinds, some questions very technical, some others more about actually what is the industrial relevance of these kind of aspects. And overall it's been very lively, very interesting, and the speakers, of course, very brilliant. So I'm very happy to be here.
Quantum computing is such an interdisciplinary field with different communities being involved. Bringing them together at events like these is fundamental to making quantum computing a success eventually.
The atmosphere is relaxed, but at the same time very serious. I think people are discussing a lot of challenges in the field that need to be addressed in order to actually have useful quantum computing, which I think is great.
We're at a very interesting time in quantum computing. We are transitioning from demonstrations that quantum computing works, we've shown that quantum error correction does work on small devices, to where the engineering challenges will really start to bite.
So I think the biggest challenges in quantum computing in general are, of course, scalability and, on the other hand, fitting hardware and software. At the moment, we have a little bit the situation that hardware is developed, increasing fidelity, making better codes and so on. And on the other side, there is algorithm design. And somehow we have to fit these things together.
There are some challenges in actually using the hardware. So the challenges vary from how do you program for it in a user-friendly way, to how do you optimize for errors and different idiosyncrasies of the hardware. And so there's a lot of software there's a lot of layers of software that go in between a user and what actually runs on the quantum hardware.
Well, I love the community. I think quantum computing is still at the stage where people are really working together.
It doesn't have to be an impossible barrier.
I've been in this community for a very long time now, starting from when I was a PhD student, and it's just great to see this community growing, from just doing very basic research about qubits and hardware to actually trying to do something that works as a system. This is an event that's really going to push forward the field. So thank you, Robert.